We are talking about properties of rational exponents and radicals, and we are simplifying the following expressions. Assume all variables are positive. And so as we look at the example here, we can't really simplify any of these exactly right off the bat, so we have to manipulate it a little bit. So what we can do is we can rewrite it so that we can split the radical into the numerator and the denominator. So cube root of x over the cube root of, and what we can rewrite the denominator as is values that will get pulled out. And so we need to have sets of 3. So y to the third, that's one set. Y to the third, that's another set. So that's 6. And that's going to leave us with 2 remaining. And so in order to get this last set here to be whole, or to make it back so that we don't have this radical up front, we need one more y. So we have one set that we can take out. We have another set that we can take out, and that's going to leave us y squared outside of the radical. So cube root of x over, we took y squared out of the radical, and then we're still left with the cube root of y squared. And so now what we need to do is we need to multiply by the cube root of y, of 1y, y to the first. And what that's going to do is that's going to make it so that this y squared and this y together, and then we'll be able to pull that out of the radical. And so when we do that, if we multiply the numerator, this is a third root, not a 3 out front. So the cube root of x times the cube root of y just becomes the cube root of xy. And then the y squared is going to stay, and then the cube root of y squared times the cube root of y. So we have y squared, and then that becomes the cube root of y cubed. And that just means that we can bring it out of the radical. And so we get the cube root of xy divided by y cubed in the simplest form. Okay. The next one, we have x raised to the square root of 3, and then we have that multiplied by 2 times the square root of 3. And so what we want to do is we want to just focus on what is happening in the exponent right now. So what the exponent says is we can multiply these two things together. So 2 times the square root of 3, and that's that, and that is going to be multiplied by the square root of 3. And that's where we got that from. So we can multiply this together. When we multiply this together, we keep the same things under the radical. So 2 times the square root of 9. 3 times 3 is 9. Then we can say that we know what the square root of 9 is. So 2 times 3. 2 times 3 is 6. So the solution is x to the 6th power. If you're wondering where the x came from, the x was there the whole time. We just rewrote the exponent. So that was x to the 2, x raised to the 2 times the square root of 3 times the square root of 3, x raised to the 2 square root of 9, x raised to the 2 times 3, and then x raised to the 6, and then that was our solution. The next one we have we have to distribute our -2 to both terms here. So if we distribute the -2 in, what we're going to do is we multiply the numerator and leave the denominator. So we get x to the -10/3 times x to the -14/2. In this case, we know that we can reduce this, and it just is going to become x to the 7th. And the negative sign, in order to get rid of the negative, we have to move both terms to the denominator. So that becomes 1 over x to the 10/3 times x to the 7th. So if we have the same base joined by multiplication, what we can do is we can add the exponents. And so when we add the exponents, another way to write 10/3 is actually 30. So when we 10 to the third is actually 3 1/3. 3 1/3 added to 7 is 10 1/3, which is 31. So that's going to be 1 over x to the 31/3. Well, the thing that we don't like about that is we don't quite have an exact perfect cube root in the denominator, because 3 does not go into 31. And what we want to have is some exact factor of 3 in order to get rid of the radical. So 30 would be an exact factor, but that doesn't work. So how do we get the next one? The next one's 33. So we want to try to get our numerator to become 33. And what we have to do is we have to add 2/3 to that. And the way that we add 2/3 is we have to multiply both the numerator and the denominator by x to the 2/3. This is equal to 1, so it's not going to change the value here. And when we have two bases joined by multiplication, we can add the exponents. So in this case, 31 1/3 and 2 1/3, and that becomes 33. So the numerator for this just stays 1 times x to the 2/3, which is x to the 2/3. And in the denominator, we get x 33/3. And the reason that we multiplied by 2/3 is we wanted to get rid of that denominator in the exponent, which in this case it does, because 33 divided by 3 is 11. So that becomes x to the 11th in the denominator, and the numerator stays the same as x to the 2/3. And that is in the simplest form. Next example that we come to, we want to try to reduce this as much as we can. And so the first thing that we can look at is we can look at our numerators or our coefficients here, and we can reduce those. So we can take a look at 81 divided by 27, and 81 divided by 27 is just 3. So we're still going to have the cube root, and we're going to work to see what we get left, but the 3, in that case, the 3 goes in the numerator. Okay, so we dealt with our coefficients. The next thing that we come to is we come to x squared in x, and the way that we can write that is we can write that as x squared over x to the first. And so we have 2 x's in the numerator, 1 x in the denominator, and so the x cancels, and what we're left with is just 1 x in the numerator. So we went with the coefficients, we went with the x's, and then the next thing that we come to is the y values. So we have y to the 5th in the numerator, and we have y to the 6th in the denominator, but we have one more y in the denominator. So we lose all the y's in the numerator, and we lose that 6 because we take away 5, so we're still left with one y, but this time it's in the denominator. And so what we want to do is we put that in the denominator, and we get just y. And the last part here, as we look at, we don't have any z's in the numerator, so we have to leave z squared in the denominator because there's nothing to cancel in the numerator. And so we've reduced this as much as we can right now. Want to just make sure that it's clear that both the numerator and the denominator are still cube rooted. So this is the issue right now. The numerator, that we're okay with that, but what's going on in the denominator is we cannot have the radical in the denominator, so we have to get rid of that. And the way that we get rid of it is we have to multiply both the numerator and the denominator by the cube root of y squared, or the cube root of y times z squared. No, that's not right. Let me rewrite this. So in the numerator, we have the cube root of 3x, and in the denominator, we have the cube root of y times z squared. We need to get a set of 3 z's and a set of 3 y's in order to pull those out of the radical. So we have 1 y, so we need to get 2 more in order to get 3 of them. So we still have the cube root, and we have 1, we need to get to 3, so it's got to be z squared. We have 2 z's, and we need to get to 3, so we need to multiply by 1z, and that will eliminate our radical from the denominator. So whatever we multiply by the denominator, we have to multiply by the numerator. So that's y squared z, cube root of y squared z. And then we can go ahead and we can do the multiplication. So we get 3x times y squared z. That's just going to stay under the denominator, or under the radical, cube root of 3x y squared z. And then in the denominator, the reason that we multiplied by all of this is because we're going to simplify that radical. So we get cube root of y times y squared is y cubed, z squared times z is z cubed, and then what ends up happening is all of our radical cancels our exponents in the denominator, and so the simplest version is the cube root of 3x y squared z divided by yz, and that is the simplest version.